Good afternoon.
Good afternoon.
Sanibonani. Goeienaand. Goeienaand. I wanted to find out how you say good evening in Yoruba. Ekurole. Please be seated. Professor Salki Gravit, goeienacht means good evening.
It means good night.
You see, in African languages, certainly South African languages, good evening and good night is the same thing. Yeah. Professor Charles Mbohwa, Acting Executive Dean of the Faculty of Engineering and the Built Environment. Professor Esther Akinlabi, the professor that we are going to be inducting tonight. Professor Jyotsna Dutta Majumdar from the Indian Institute of Technology in Kharagpur. For those of you who do not know what the Indian Institute of Technology is, these are a group of prestigious technological universities in India. Senior leaders of the university, I see Professor Gravit, I see Professor Sina, I saw someone who looked like Professor Shirin Mutala. Okay, you are hidden, and all other people that I have not been able to see. Members of Senate and other academics, distinguished guests who have taken time to come and witness this ceremony. Ladies and gentlemen, Sanibonani. Goeienaand. Good evening. Tobela. It is indeed a great honor and special privilege for me to welcome you to the Professorial Inaugural Lecture of Professor Esther Akinlabi. As I do so, I wish to express a warm welcome to her beloved ones, her husband, Stephen. Stephen, if you could just stand so that you could be acknowledged. Coincidentally, Stephen was my PhD student many years ago. Special guests and her colleagues. I have not seen your children. If you could be acknowledged also, if you could just stand up. You have to do an inaugural lecture sometimes. But tonight is not your night, it's your mother's night. I'm seeing a lot of people from the Faculty of Engineering. It almost feels like home. I used to be the Dean of the Faculty of Engineering. The faculty has changed. See people from the College of Business and Economics. Professor Daniel is also here. This is indeed a proud and joyful, yet a landmark moment for all of you. For Professor Akinlabi, and of course for us here at UJ and higher education in South Africa and beyond. The inauguration of professors is a public ceremony in which newly appointed professors are inducted into the office by the Vice-Chancellor and deliver their inaugural addresses so that the public can be able to know what they are doing. The ceremony has its roots in the medieval university and serves multiple purposes. Firstly, it is an expression of welcome and entry for new professors joining the circle of colleagues who are already professors. Secondly, it provides a platform for the professors to display their expertise in the discipline and showcase their research. In isiXhosa, we say, ukuthweswa izidanga kwisigawa sowujinga lwazi. Professor Pichana, have I done it correctly? Have I done it correctly? Yes. No, thank you very much. You are very kind. You see, Xhosa is only my 11th language. You know? This loosely translated refers to assuming the role of the professor. Of course, in colonial traditions, subscribed by universities, this refers to the gown and the cap. And the gown and the cap was actually inherited from the Catholic Church. The concept of a modern university actually originated in the Catholic Church. In fact, some of the first universities in the world, the University of Paris, the University of Bologna, the University of Oxford, and the University of Cambridge, were actually Catholic institutions. Traditionally, in an African settings, the wise people normally received a blanket, ingubo. Once we have listened to the inaugural address, the gown or ingubo, denoting the professorship, will be formally assumed by Professor Akinlabi. Today we gather to bear witness to the entry of Professor Akinlabi to the illustrious community of scholars at the University of Johannesburg. Last week we were giving an honorary doctorate to Professor Engela, who won a Nobel Prize in 2003 for his work on co-integration. That is a concept in mathematics and economics. And today we are going to be inaugurating Professor Akinlabi. I think let's give her a round of applause. It is a celebration of the contributions to the discipline and ultimately the impact on society. One wise woman once said, "Knowledge only becomes education when it finds a purpose in society and fulfills it." Close quote. Professors provide a university with its identity, character, and academic legitimacy and integrity. Therefore, professors are supposed to profess to their students and to the wider community. The inaugural lecture in which they profess is a rite of passage following the confirmation of the appointment of the person as a professor. This evening, we will listen to Professor Akinlabi as the gown goes to town. By this I mean that the power of the inaugural address is when the expertise is showcased beyond the corridors of the university and reverberates in society and through to eternity. It stands out as a moment of pride for the incumbent, the family, fellow scholars, the university, and ultimately society. For the German philosopher and diplomat Humboldt, a university referred to the whole community of scholars and students engaged in a common search for truth. Newman talked about teaching universal knowledge. Recently, universities have been viewed as instruments serving the purpose of the economy, of society, and of the politics. I would hope that we can break out this narrow conceptualization and reflect on the university as contributing ultimately to public good. Edward Said, in an article on defiance and taking positions, offers a formulation of the ideal role of the true intellectual as one who commands a vast knowledge of his or her discipline, who is rigorous in the analysis of literature, who views being an intellectual as a vocation. the intellectual who considers it necessary to step into the public sphere and to speak truth to power, namely to question, interpret, and understand authority, than consolidating it. To step out of the boundaries of the academy, to connect oneself, to affiliate oneself, to align oneself with an ongoing process or contest of some sort, perhaps with the aim of proving the lot of the oppressed. The intellectual who functions as a kind of public memory to recall what is forgotten or ignored, to make the connections that are otherwise hidden, and to provide alternatives to mistaken policies. In short, the aim of an intellectual is to ask questions. As Albert Einstein puts it, the measure, I quote, the measure of how wise or clever you are is not by how many questions you can answer, but by how many questions you can pose. Close quote. It remains then for us as a university with a Pan-African vision to derive our mandate as intellectuals and as professors from society. How do we embrace the role of a professor as a disruptor of ideas while continuing to be flagship carriers of our disciplines, all in service of society? This evening we will listen to Professor Akinlabi as one further step in the journey of being a professor. This is a journey which does not culminate once this lecture has been given. It is a self-reflective pause in the journey of the professor with a promise of more to enrich our minds and simultaneously contributing to the rich intellectual body of work in the discipline. In summary, as professors, we should criticize, self-criticize, and question ourselves and our ideas time and time again. Let me now invite the Executive Dean, Professor Charles Mbohwa, to introduce Professor Esther Akinlabi. I thank you, Kialibua, Siyabonga Bayadanki, Enkos.
Good evening, ladies and gentlemen. Vice-Chancellor, it is my honor to introduce Esther Akinlabi. Esther T Akinlabi, ni Orunifemi, was born in Kaba, Kogi State, in Nigeria. Her first degree in agricultural engineering and a master's in mechanical engineering were from the Federal Institute of Technology, Akure, as well as the master's from Port Harcourt in Nigeria. She did her doctoral studies at Nelson Mandela Metropolitan University, now called Nelson Mandela University. After the award of the first degree, she had a chance to work in industry, where she did quite well, and in that time was also a temporary academic at universities in Nigeria. Professor Akinlabi currently serves as our Vice Dean, Teaching and Learning in the Faculty of Engineering and the Built Environment, where she serves with distinction. She was our first female head of department for the Department of Mechanical Engineering at the University of Johannesburg from January 2015 to April 2017. Just a bit about her research. Her PhD was on friction stir welding, which was looking at processing of dissimilar materials, especially aluminium and copper. And from that work, she has built a lot of profile. She started at the University of Johannesburg as a lecturer in November 2010 and grew through the ranks to associate professor and later on as a full professor. My major interaction with her was from the time when she was associate professor, when she walked into my office and said she wanted me to mentor her, but over time, in some cases, the mentee became the mentor. In the past 7 years, she has done an excellent body of work in terms of her research, mainly focusing on advanced modern manufacturing technology and systems, working furthermore in additive manufacturing in collaboration with the Center for Scientific and Industrial Research in Pretoria. She has done quite a lot in terms of laser metal deposition and working on functionally graded material. Some of the work has looked at cladding titanium with titanium carbide, and this work has also extended to bio applications, where you look at compost material applications. More recently, she has been doing some work also in renewable energy. I know I've worked with her on the biogas project with the city of Johannesburg, working also on wind and solar technology. She has also been a mentor, and I think from the summary you see that she has done a lot of work with students, with over 20 PhD students currently and 12 master students. But also what's not indicated is that she had mentored female heads of departments, which now constitutes more than 30% or close to 40% of the administrative staff in the Faculty of Engineering and the Built Environment. She has graduated 7 PhDs and several masters, and has also published 2 books, edited 1 book series. She has authored more than 200 peer-reviewed articles that have brought in quite a lot of also income to the university, and has filed 2 patents. She has reviewed for many international journals. She has been a guest speaker and a keynote speaker at different international fora. She is Y2 National Research Foundation rated researcher. And I think from what I'm saying, you can tell that re-rating maybe is overdue, but that's coming soon in terms of her profile. She has also had a lot of funding, subsidy for working with CSIR, and in terms of funding from ESCOM, United Kingdom, and from many sources of donors and funding agencies. She has collaborated with many expert researchers, and today I think the response from the keynote will be from one of her collaborators, a distinguished professor from India. And she's a woman, I think, who has distinguished herself in terms of the work that she's doing, and exercises excellence and passion in whatever she does. Just to summarize in terms of recognition that has come her way, In 2017, she was a recipient of the top 50 inspiring women in South Africa, an initiative which is coordinated by the Kingdom of Netherlands. She was also awarded in 2017 the Overall Academic Excellence Award from the Old Mutual in South Africa. In 2016, she was a winner of the Distinguished Young Women Researcher Award in the category Physical and Engineering Sciences, offered by the Women in Science. She also got the Women in Science Award. In 2015, she was recognized for excellence in teaching by the Congress of Nigerian Students of the University of Johannesburg. She was also a finalist of the T.W. Kambule NSTF Award, recognizing her outstanding contribution to science, engineering, and innovation. In 2014, she was a recipient of the UJ Vice-Chancellor Distinguished Award for Innovator of the Year, and I think you have seen that she has a number of patents. She was also awarded Excellence in Engineering and Technology in Academic Research Award from Women in Engineering and the Built Environment. She's a member of South African Young Academy of Sciences and is a registered professional with the Engineering Council of South Africa. So I think that introduction sets the scene for her, and I'm sure now you are eager to go and to listen to her. Thank you, Professor Akinlabi.
Thank you, Prof. Mbohwa. Good evening, our esteemed Vice-Chancellor of Tshilidzi Marwala. Good evening to Professor of Sina, representing the MEC this evening, and to the members of the Executive Leadership Group, Prof. Sarah Gravit and Prof. Daniel, to the members of the Senior Leadership Group of the university, to colleagues from other universities present here this evening, to many of my friends, my students, and to my families. You're all welcome to my inaugural address, which I have titled, Joining All About Life. This is the outline of my presentation. I will start with a brief introduction, give some fundamentals in the field of welding. I will go ahead and highlight some of my personal contributions to the field of friction stir welding in particular, and in the field of laser-based additive manufacturing. I was just wondering behind my computer when I was trying to put the slides together, when you received your invite and you saw the title, Joining All About Life, I was wondering what was going through your mind at that particular point in time. Did you actually agree with me? Did you? Or you did not? So I was just wondering, perhaps you strongly agree, or you said, no, joining cannot be all about life. Or you were just neutral and said, well, let me get there and go hear what Esther is got to say about this particular topic that she's put together for her inaugural address. I'm hoping that after this address this evening, I'm hoping that I will be able to convince you that indeed joining is all about life. You will agree with me that scientifically, human life started with the fact that there was a joining. The sperm cell and the egg cell had to fuse together in a natural way. There was a joining that happened. And in that, I'm standing before you today because a joining took place some years ago. And I believe you agree with me. Despite the advent of the 3D technology, where we build component parts at one go, I still believe strongly that many of the components we use in our homes, even in this auditorium where we are today, the chair, the table, they're all pieces of various components that were put together. And you will agree with me that the majority of what we use on a daily basis has one element of joining or the other. I hope you all following me on this journey. And I hope I'm already beginning to convince you that indeed joining is all about life. The first metal recorded in the literature to ever be joined in history happened to be copper. And since then, it's still being used, finds its application today. And copper has been used ever since in history and still continues to be joined today because it is a material that is very, very malleable, easily hammered and can be easily bent. And it finds its applications in jewelries, in coins, and many other applications. The history of joining dates back to 5000 BC, and it was first recorded in the literature in Greece. The Greek researchers at that particular point, at that time, used copper to produce the coins that they spent in Greece. And they were the first to produce coins from copper. From there, the use of copper as to produce coins then expanded across the world, up until even here in South Africa as well. For us in Africa, welding was believed to start about 4000 BC, also with copper as well, and that was recorded in Egypt. Not until 1330 BC, when the Golden Death mask was produced by joining copper materials together as a funeral mask for the King Pharaoh at that particular year. And in general, with civilization over time, the joining of materials then extended from only copper to several other materials. And even today, we also join plastics, not only metals now. Welding can be categorized into two major groups. One is the fusion welding, wherein the materials has to be melted before they can be joined, and usually with the use of an electrode. And that is the welding technology that is very, very popular that we all know about. The roadside welders, that is what you see them using their welding machines to do. Further to that, some decades ago, we then have the solid-state welding technology, wherein the materials does not have to be melted. Technology then improved with the solid-state welding because it has better properties compared to the fusion welding technologies. And among the 6 solid-state welding technology, the latest of that technology happens to be friction stir welding. And that is my own passion, and it happens to be the field that I have worked on in the past 10 years of my career. Friction stir welding technology was invented in 1991 by Dr. Wayne Thomas, who was a welding engineer at the Welding Institute in the UK. The process is a continuous process wherein we plunge the welding tool through the machine, and we plunge into the abutting surfaces, we stir, and then we join two materials together, leaving behind a solid phase joint. The process is very suitable for all kinds of joints and for all kinds of materials. And the welding temperature happens to be between 60 and 80% of the melting temperature of the base material. The picture you have here, this is Dr. Wayne Thomas here, who is the inventor of the friction stir welding technology. And this is Prof. Santos in Germany, and here is Esther. This picture was taken in 2010 in Hamburg, Germany, when I went for a conference, only on friction stir welding. It was a privilege and an honor for me to meet Dr. Wayne Thomas. And since then, we have maintained a very good relationship. And I'm very happy that I have such a father figure in the field that I am working on. I will now show you a very brief video of the friction stir
Pieces to
welding
be joined are aligned in a
process.
friction stir welding machine, then clamped into a stationary position. When the rotating pin tool reaches a predetermined speed, it is axially plunged into the workpieces, creating frictional heat at the interface. As the material softens, the pin tool continues to axially move into the pieces, expelling flash material from the interface. Once the pin tool reaches the proper depth, the pin tool's shoulder contacts the material surfaces, generating frictional heat under the tool's shoulder. While maintaining part contact, the pin tool moves through the workpieces, softening the material along its path. The material is swept from the leading edge of the pin tool to the trailing portion where it is reconsolidated into the weld trough. After the programmed weld path is complete, the pin tool is moved to a non-critical area of the workpiece where it is then extracted from the part.
Thank you. The technology comes with a lot of benefits compared to the fusion welding technology. It comes up with excellent joint properties. It's a green technology. And compared to fusion welding technology, there's no fume, no smoke that is produced, as you can see from the video just now. It's an environmentally friendly and energy efficient process. The first friction stir welding application on a commercial basis was in 2004, wherein the US government gave a funding award of about $300 million to TWI to conduct research. The scope of what they had to do was to produce this Eclipse 500 business jet, and airplanes generally has a lot of riveted joints on the panels. So the assignment of these researchers was to remove riveted joints in panels of this plane and replace with friction stir welding, because the researchers at that time told the government that they can reduce the weight of aircraft, thereby saving energy. So they were given this assignment, and this project was concluded in 2006. And indeed, they had 60% savings on the weight and great improvement in the fuel efficiency of the 500 business jet. And that was the first successful commercialization of the process. In August 2017, under the Royal Academy of Engineering of UK funding, 3 researchers, myself from UJ, I have Dr. Shongwe from TUT, and Dr. Suni of Sisulu University. We had a joint proposal wherein we were on board and off to TWI. And we had some of our students with us, and these were photos that we took at the Welding Institute in Cambridge, UK, in August 2017. The technology has then since grown over time and has been greatly commercialized. One commercial application I'm going to leave with you this evening is the use of the process in the underground tubes in London. When next you visit London and you're stepping into the underground tube and you hear, please mind the gap between the train and the platform. Remember, you're jumping into a train that has friction stir welds on its panels. I hope you will do me that favor. You will not forget that particular point for this inaugural address. Other applications are found in shipbuilding, petrochemical industry, and many other applications. Now coming to Africa. Friction stir welding technology in Africa. The friction stir welding platform at the Nelson Mandela University happens to be the first friction stir welding platform on African soil. And I was privileged to be the first PhD candidate that worked on this platform. So I can say that Esther is the first PhD in the field of friction stir welding in Africa. Thank you. Since graduation in 2011, I have then since continued to collaborate with my alma mater at the Nelson Mandela University with Prof. Hatton. And from time to time, we visit the university with quite a number of my students. And this was one of the photos on one of our trips. I have Patrick here, who is now a postdoctoral fellow with me. This is the operator of the machine. Here you see Esther. And this man is my co-researcher in the field. My personal contribution in the field of friction stir welding is in joining of aluminum to copper. Up to date, there is no electrode that can join aluminum to copper. Reason because of the huge difference in the melting temperature of aluminum and copper. Copper will melt at 1085, while aluminum will melt at 560 degrees centigrade. So there's still ongoing research, perhaps tomorrow, I'm not sure. But as tonight, there is no electrode that can join aluminum to copper, not on fusion welding. So this is my personal contribution, wherein I was able to successfully join aluminum to copper using a friction stir welding process. And this particular work has been supported and sponsored by ESCOM. The process is a very complex process, not as simple as going to the lab and you do one or two welds and you are good to go. It's not as simple as that. There's a lot of processing parameters, quite substantial number of processing parameters that has to be optimized. The welding tool has to be optimized. The tool material also has to be optimized. And these I was able to achieve by using design of experiment to come up with, to be able to achieve welds with good integrity. And when we conduct welds, we always want to ascertain the joint integrity. And in so doing, we then have to characterize the welds, either through materials characterization, mechanical property, mechanical testing, corrosion test, X-ray diffraction, electrical resistivity, residual stresses characterizations, depending on the typical application that the weld is intended for. And these are some of the results for joining aluminum and copper. Starting at UJ, we do not have a friction stir welding machine at UJ. And I needed to continue my research work. So what I did was to get some students together in 2011. We designed the fixtures, the backing plates, the clamping fixtures, and the tools and all of that. And off we go. We reconfigured a milling machine at the Mechanical Engineering Science here at UJ, and successful welds were conducted. And quite a number of students had their the final year projects, and also some master students used the reconfigured milling machine for about 2 to 3 years. I then went further to Toolquip and Allied, a company here in Johannesburg that are into sales and maintenance of milling machines. They also opened their doors to us, and we did have some time to play on their shop floor. They opened their showroom, and we were able to, we successfully reconfigured quite a number of their milling machines to produce welds in that particular year. Here in the photo, I have Maleka here. This is my humble self, and this is Willem and Clark. And we're able to have quite a number of welds produced at that particular year. Further to friction stir welding, I then moved ahead and conducted some work in surface engineering. That is, improving surface properties of materials. In particular, I was looking at aluminum, on how to improve the properties of aluminum. And in this, I conducted some work on friction stir processing of aluminum by incorporating titanium carbide particles to improve the wear properties, and this was highly successful. And applications of these are found in aerospace and the automotive industry. With this particular slide, this is the last slide that is reporting, highlighting my work in the field of friction stir welding. The next couple of field slides will highlight the work that I've been able to do in the field of laser-based additive manufacturing. And in the field of friction stir welding and processing, to date, I have successfully published over 80 papers in this particular field. Thank you. Now on laser-based additive manufacturing. In response to the Department of Science and Technology and the National Research Foundation some years ago, there were calls for proposals for researchers who would like to work in the field of titanium and its alloys. And I'm happy that I have Prof. Sisa in the room today, and Prof. Claudia Polise as well. They have been my collaborators over a number of years in this particular field. The government identified the fact that South Africa as a country, we have titanium and its alloys in abundance, but this is in the ore form and has to be processed and useful for end users. And titanium is a material that has excellent properties, excellent corrosion properties, and has been extensively used in the aerospace industry, biomedical industry, and in the marine industry as well. The laser additive manufacturing technology is very similar to the 3D printing that you are all familiar with. The only difference being that for 3D printing machines that we are all familiar with, component parts are printed from plastics, from ABS plastics. But in for the case of the laser-based additive manufacturing, we produce component parts from metallic powders. And the laser additive manufacturing, also referred to as the LMD, which is laser metal deposition, uses the laser. The laser assists to generate a pool of, by melting the component surface, and the nozzle automatically delivers the powder, leaving behind a deposition. I will now show you another very brief video telling you about how the laser metal deposition works. This particular video is showing how turbine blades are built. We always have a substrate, and we build on the material, and it's usually a near net shape. After the building, we are able to easily remove the component part that is built. So as you can see, with the nozzle, builds the material layer by layer until the full 3D component is formed. Further work on laser-based additive manufacturing was a study conducted by one of my PhD students that I supervised to completion, Dr. Monamet Lotling, and this was in the field of cladding titanium with hydroxyapatite coating. The background to this study is the fact that this is the titanium alloy grade 5 with aluminum and vanadium. It's been reported in the literature that over a certain number of years, 5 years and above, this aluminum and vanadium deionizes into the body stream, causing some diseases, particularly the Parkinson disease. There was then a need to coat implants that are made from the titanium alloy grade 5. We then use the hydroxyapatite coating. This is our own photo taken at the National Laser Center of actual hip implant that was being built under the laser system. And these are some of the results showing good bonding and good results from that study. Another study conducted in this field was cladding titanium with copper. And this was also conducted by one of my PhD students, now a postdoctoral fellow, Dr. Foley Eriosho. In this particular study, the study is related to marine applications, in that we're trying to prevent biofouling. Biofouling, that is when we have accumulation of microorganisms on the body of the ship in the water. And this is also referred to as epibiosis. In this particular research, after cladding the titanium alloy grade 5 with copper, we observed that we had composites with good bonding, with excellent properties. And this was conducted by using simulated sea water. Still on this particular study of titanium alloy and copper is with respect to the fact that these two materials are also relevant in biomedical implants. The risk of copper deficiency is much higher than the excess of copper content in the body. And copper has been known to stimulate a warm flow of healing energy in the body. When copper is deficient in the body, it's been reported that it can lead to health problems such as anemia, cardiovascular diseases, impaired brain function, obesity, and depression. And on this slide, I have put some copper-rich food here as a take-home for everyone here today. That when you see this food when you do your groceries, and you come across these food items, please pick them from time to time, because they will help you so that you will not have copper deficiency in your body system. And that is sunflower seeds, beef liver, lentils, almonds, dark chocolates. I know the children were very happy about that. And mushroom. Perhaps you're wondering, is this health science talk? No, it is still in the field of material science and mechanical engineering. Further work on laser-based additive manufacturing are the work that I have conducted in the field of functionally graded materials, popularly referred to as FGM. FGM started in Japan about a decade ago, wherein researchers observed that when laminate composites are used at high operating temperatures, the material tend to delaminate at the joint interface. They needed to come up with a material that is functionally graded in order to eliminate the joint interface. In so doing, they then came up with by varying the composition and the structure in the material over the volume, similar to what I have in this particular picture. And on this note, myself and one of my postdoc, we've been able to publish a book, and that is the cover page of the book here, on functionally graded materials. So please, after this lecture, look out for the book and purchase your copy tomorrow. FGM occurs in nature, naturally. In human femur, we have materials in the body that are FGM. The human teeth has also been reported as an FGM. It comprises of calcium and hydroxyapatite, HAP. And last year, we also had a discovery when one of my PhD students working on bamboo, we're working in the lab, and he invited me. He said, "Can you please join me? I'm seeing something. I'm not so sure of what I'm seeing." Then I joined him in the lab, and he said, "What kind of structure is this?" I said, "You know what, Richard? What we have here is an FGM." He said, "What does that mean?" And I explained to him. And this was a discovery that the cellulose of bamboo is actually an FGM. As you can see, these are bamboo, the cellulose of bamboo. We then went ahead to write a book, and we titled it Bamboo. So again, after this lecture tomorrow, please look out for that book on the internet, published by Springer on bamboo, so that you can know more about what we have done. Typical applications of FGM are found in petrochemical and the mining industry, automobile, defense, aerospace, medicine, and in optoelectronics. And the technology is growing and really, really evolving to solve a lot of problems today. In this particular field, I have further conducted some research work on FGM by functionally grading titanium and titanium carbide. In this particular work, we're trying to improve the wear properties of titanium alloy grade 5. Titanium alloy grade 5, though has excellent corrosion resistance behavior, it has poor wear resistance, where it involves where two components will have to rub on each other. And this particular study, what we're trying to do was to replace the tungsten that is used in producing landing gear of aircraft so as to reduce the weight of aircraft. And this particular work, I have been to Denel Aviation to present this work with them, and talks is ongoing with that. And we've had successful results from this particular work as well. Also, I have conducted functionally graded materials into stainless steel. Stainless steel still very relevant today. Finds applications in the use of household utensils, cutlery that we use on a daily basis, cooking pots, and biomedical implants, and also in the petrochemical industry, because it has an excellent corrosion resistant property. In this particular deposition, if you look at this this cross section, you will observe that from A to E, the materials have been functionally graded, wherein we have introduced various percentage volume of 316 into 17.4 pH. Now, looking at these pictures on this end here, this C, D, E were taken at different levels of the material. Yet, you will observe that they all look very, very similar, whereas the compositions are very different from one another. And when we observe this type of outcome, we say the material has experienced an epitaxial growth. And this has been a successful work as well. This particular slide then ends my work in the field of laser-based additive manufacturing. And I will now move on to talk about this particular slide. With the strategic direction of the University of Johannesburg on Fourth Industrial Revolution, I believe that my address will be incomplete if I do not talk about the Fourth Industrial Revolution. I don't want Prof. Marwala to stop from giving my gown this evening. So in so doing, I then did an assessment of these two technologies that I've been busy working on in the last 10 years. And I compared, I related Fourth Industrial Revolution to friction stir welding and to laser-based additive manufacturing. And I realized that the two technologies are compliant. So Prof. Marwala, thank you very much for that direction of the university where we're going in the Fourth Industrial Revolution. So on this note, I can convincingly say that the two technologies are they are both fully automated. They are very flexible in operation. They operate at high speed, high accuracy, and easily repeatable. I also want to share something with you here. Perhaps you're looking at this screen and say, what is this screen doing here now? Other pictures are very, very clear. But this particular one, I want to show you that Apple slims down iMac 40% with friction stir welding. If you have iMac at home or in your offices, in the frame of the iMac, friction stir welding technology has been used to produce the frame of iMac, and the weight has been reduced by 40%. And this has been used since 2012 till date, and they are still using it up until now. So the two technologies, I can confidently say they are compliant with Industry 4.0. Further to that, I also looked at the sustainability of the technologies. And I realized that both technologies are energy efficient. They have efficient cooling system. They can be considered as green technologies and save cost at the long run. On life cycle impact assessment for both technologies, they have low environmental impact index, low impact on human health, and they both have improved ecosystem quality. Look at this particular gentleman here. That is Esther, flagging the rent equivalent there. So I said, for economic viability, don't ask me yet about the rand value of the equipment. The rand value for friction stir welding, the last time I checked, is going for about 15 million rands. And the rand value for a complete laser system to produce laser-based additive manufacturing product is over 100 million rands. So I'm going somewhere with this economic viability. Other research interests that I'm also into is biogas generation from fruits and vegetable waste. Perhaps after this lecture, if you collect enough, up to 10 kg of waste in your kitchen, please call on me and I'll come and collect them. And then I'll give you gas in exchange for your waste from your kitchen. So please take note of that as a take home from this lecture. A lot of work is also being done in bamboo reinforcement, which has also been very successful as well. In summary, I have provided a background and fundamentals into welding, and I have given highlights of my personal contributions in the field of fission steel welding and the field of laser-based additive manufacturing. Both technologies can be considered as being global, highly competitive, and they have a lot of relevance in the industry. Both technologies can also be considered as being multidisciplinary in nature. Having worked in these fields in the last 10 years, I've had the opportunity to work with many other researchers in various fields of expertise. I've had to work with physicists, I've had to work with chemists, I've had to work with materials scientists, I've had to work with civil engineers, mechanical engineers, and so many other people in diverse fields. Some were wondering, perhaps, maybe after this inaugural now, at least she can rest a little bit. Perhaps. I'm not resting. I have a focus. I have a future direction. And what I'm saying is, I'm Mandla. That is power to the people. Away too. So, I'm Mandla. So, going forward, for me as a researcher, my plan is to collaborate with other researchers in this field of expertise and come up with cost-effective friction stir welding and laser-based additive manufacturing machines that will be affordable to small, medium enterprises. And I believe that this will lead to job creation and automation. And in so doing, I will continue to contribute in this particular field by preferring African solutions to African problems in the field of joining, yet globally competitive. These are some of the references consulted, particularly the pictures that I've taken from the internet, some of them. And on acknowledgement, I would like to thank many people who have been with me through this journey. It's been a very great one. And I would like to start by thanking my husband, Dr. Esther Akinlabi. I call him the love of my life. And I say MD. He's been with me all the way. And in the midst of it all, I look back and all I have to say is to say thank you. The fact that he believed in me even more than I believe in myself. When I look back at the various ways in which he has really pushed me to where I am today, I want to say thank you. And to my children, Aki and Stephanie, thank you for your moral support. I know that you always tell me, Mommy is too busy. And I'm hoping that I have not been able to make you not to, I hope I've been able to convince you that you should also become professors in the future. I would like to thank Prof. Tshilidzi Marwala, who has been very supportive from the beginning. When I joined UJ, then he was the Dean of the Faculty of Engineering and the Built Environment. He gave me all the necessary support, and he gave me all the platform to be able to grow. And as he was leaving the faculty, it was as if he handed me over to Professor Sina. Prof. Sina then continued and gave me all the necessary support to ensure that I have grown in my career. Thank you very much for your support. Prof. Mbohwa mentioned something that he said mentee became mentor. I disagree with you. Prof. Mbohwa is my mentor. When I joined the accelerated mentorship program, he agreed to mentor me from associate professor to the full professorial level. And the very day I was promoted to full professor, he called me and said, now we are colleagues, so I'm no longer mentoring you, so now you're on your own. Thank you very much for your support. To various collaborators that I've had, and particularly this evening, I'm highly humbled and honored to have Prof. Majumdar with me today. Thank you very much for coming all the way from Kharagpur. I am highly humbled, and I really thank you for being here today. To my research team, formidable, modern and advanced manufacturing research group, you are all here today, and I look forward to attending all your inaugural lectures as well in the very near future, because I know I'm producing many more professors that are even going to do better than me. And to many of my collaborators in the US, I have Prof. Kumpati here of MSOE in the US, Sheku Kamara, and we have a number of students and colleagues around. And this is Prof. Annelies Elsbotes, who supervised my doctorate work at Nelson Mandela University. I want to say thank you to everyone. And to all my colleagues who have given me all the necessary support, who are also here this evening as well. If I have to start to mention your names one after the other, I believe we'll leave here tomorrow morning. And I don't want to take your time longer than this. I also recognize my uncle, a professor from the Northwest University, who traveled all the way to be here to honor me this evening. Thank you very much. And to everyone, all my friends and families who are here this evening, I want to say a very big thank you to you for coming to honor me this evening. And I know that God will honor you as well. Now to wrap up, quite a number of my sponsors, the CSRR, the Royal Academy of Engineering in the UK, UJ has been very supportive. I've received funding from the university, ESCOM, the National Research Foundation, the National Science Foundation, and also the Carnegie African Diaspora Fellowship Award as well. And on this note, I would like to say, Kiale Boha, Baya Danki, Eshe Pukwo, Siya Bonga. Thank you.
Esteemed Professor Marwala, Professor Mbohwa, Professor Akinlabi, distinguished guests, and ladies and gentlemen, good evening to all of you. It is indeed a great pleasure and honor for me to be here in the Professorial Inaugural Ceremony of Professor Akinlabi. Professor Akinlabi is known to me since the year 2014, when she visited IIT Kharagpur in collaboration with myself and Professor Sisha Pitwana under the DST NSF collaboration program. Since then, we had been interacting with each other in academic collaborations, as well as we organized several conferences together, and we worked in the book chapters, and also we are in the process of supervising one joint student. So the collaborations as well as academic interactions ended up with new important works in different areas like laser materials processing, the bioimplant materials by surface engineering process, advanced characterizations, and many other field of activities in the area of material science as well as manufacturing. In fact, I am here today because we had a strong bonding between us, and this is the theme of our topic of our lecture in this particular inaugural function. So Professor Akinlabi has delivered an excellent talk covering a wide spectrum of joining of materials and manufacturing in manufacturing technology, starting from its utility in the human evolution to its application in machines and different components. So I was indeed wondering the way she made her journey from the very beginning of human evolution to the machineries and application of hybrid technologies, application of friction stir welding, application of laser additive manufacturing, which are really future of the welding techniques. Weldings are a very, very important part of life particularly if you talk of manufacturing technologies, manufacturing of products, it is very much integral part. And when you talk about welding techniques, it started with that all solid state welding processes like friction welding and also the hammering and solid welding processes, and then it went to the different other types of conventional welding techniques by application of different oxyacetylene gas flame as well as application of arc flame. So these things were very much old in nature, though those are conventional and people were using it quite often. But recent dated work, if you think about, you find that now those kind of conventional processing is no more there, particularly if you think about the environmental regulations, people are trying to go through their modern welding techniques which are green enough, and particularly friction stirred welding and laser welding, laser additive manufacturing, those are the categories under the green welding techniques. Now the way Professor Akinlabi explained about those techniques which are very much new and modern but still to come up because of its expensiveness in nature, particularly the cost of those welding units like friction stirred welding, and also very complex to, those processes are quite complex because you have to optimize several parameters in order to get the best result in the welded product. And the way she explained her work, it was indeed really it is, I must appreciate it, particularly the way she upgraded the typical milling unit to welding unit, that friction stirred welding unit that I did never think of. I was in fact thinking of taking this idea to my home and think of starting a friction stirred welding machine. That would indeed reduce the cost of the unit to a large extent, because expensiveness is particularly if you think about the friction stirred and laser welding techniques, for both the techniques the cost is of real importance, because if you have to install the unit in academic institution you have to think a lot. But the way he did, collaborated with different institutions, her alma mater, and did a lot of work, that is really of great, and we must appreciate her. Professor Akinlabi is a well-renowned scientist and academician who sets an example to all of us because of her ability to excel across the disciplines. For example, you saw she started her activities with welding and then went to different biogas generation related project as well as bamboo structure. So this is really and her activity actually started with agricultural engineering as her basic degree, and the way she crossed all barriers and came to mechanical engineering scientists basically, particularly in the field of mechanical and manufacturing engineering, that we must appreciate all. And being a lady, particularly I understand the barriers she had to cross in each step. Her contribution as a lady is really quite important, and we have to see that she has to excel in each and every step for getting her work recognized. Particularly her contribution in teaching and research is commendable. Her research contribution covers almost all disciplines of modern manufacturing techniques, starting from friction stirred welding to surface engineering, laser materials processing, additive manufacturing, and functionally graded materials. On friction stirred welding, particularly for the case of aluminium to copper, the way she established that particular friction stirred welding, defect-free welding, and optimize the parameters, that is really great, and for that she is among the 5% of the top-ranked researchers in this field. And her contribution to human resource development is also excellent. She produced almost 7 to 8 PhD students, several dozens of undergraduate as well as postgraduate projects she guided, she mentored, and those are really though her students will be strength in future, in a future very shortly actually. And all her PhD students are well established in their field of research. Her talent is particularly reflected from her publication records and important prestigious awards like Distinguished Women Scientist Award in 2016 and several others actually I missed, Y2 National Research Fellowship rated researchers, and several research grants from inter alia the National Research Foundation, Council of Scientific and Industrial Research, Technology Innovation Agency, Tertiary Education Support Project, grant for ESCOM, the National Science Foundation, and Royal Academy Grant of the United Kingdom. So these are all, this reflects how important she is in her field of research and how talented she is. Now, in this very auspicious day, we must give her a big hand for her steady, excellent performance, congratulate her, and wish her all the best. And not but before finishing my talk, I also congratulate her husband, Professor Dr. Esther Akinlabi, Dr. Stephen Akinlabi, and her children for supporting her all along. So with these few words, I must congratulate Professor Akinlabi once again and wish her all the best and pray to God for her very strong, passion for research, as well as her good health, as well as a successful career ahead, and also peace and happiness all throughout her life. Thank you very much.
Professor Akinlabi has professed. I think she raised very important issues that I think are at the core of our developmental agenda as a country and as a continent. And I think we should give her another round of applause. Now, by the powers vested in me, I now invite Professor Akinlabi and Professor Mbohwa to come for robing her with the trinket.